What is up, party people? Buckeye Monkey here, and I'm coming back at you, as promised, with part 2 of my series on understanding the Navball and Maneuver nodes. If you haven't watched part 1, I highly recommend it. Part 2 here assumes that you have watched it, and we build on the concepts explained in part 1. So go give it a look, or you might not understand what the heck I'm talking about here. So in this edition, we are going to explain how to get to the moon using maneuver nodes and the Navball. And so since we kind of explained all these things in part 1, let's just go ahead and jump in and get right to it. Now, the first thing you want to do here is go ahead and set the moon as a target. And you do that by just clicking on the moon and then clicking on that set target button. So what you want to do, as a general rule, when trying to get an orbit from one object to another object, is you want to pick a place on your orbit and add a maneuver node there, so that your prograde marker, your prograde handle, is basically pointed at the object that you want to get to. Then you want to go ahead and pull on that prograde handle and all the way up until the point where your apoapsis touches the orbit of where you're trying to go. You know, and if you're a little off, you can play with the handles, or you can try setting up a new maneuver node at a slightly better angle so that your approach markers, when your apoapsis touches the orbit you're trying to get to, are a little bit closer to each other. So as you can see, as my apoapsis is coming up to touch the orbit of the moon, we get those two markers there on the moon's orbit, and those represent our closest approach to the moon. And generally what we want to do is tweak our maneuver node in order to get those markers to slide towards each other until finally at some point you'll switch from approach mode to encounter mode. There we go. And in encounter mode, it will show you your expected periaps if you hover your mouse over it to, in this case, the moon. And you can play around with all 6 handles to try and get that periaps as close as possible. You know, make little tweaks to your trajectory. You know, a good periaps for the moon is about 20,000 meters from the surface, because that'll get us close enough to attempt a landing, but not so close that we risk running into you know, a high mountain or high edge of a large crater. So you just keep experimenting and pull on a handle a little bit and then mouse over the periaps to see how close it is, pull on the handle a little more, mouse over, and you just keep tweaking a little bit until finally you get that periaps to kind of what you want it to be. So here we are, we've got our maneuver node for getting to the moon pretty well set up. And a couple things here. This green dotted line represents what's going to happen to our orbit as a result of passing by the moon. See, we've got ourselves on a trajectory for a moon encounter. And while we're in that moon encounter, the gravity of the moon is going to throw us around a little bit. And as we leave the moon's sphere of influence, as we leave that encounter, what's going to end up happening is our orbit will end up looking something like this green dotted line here. But we don't really want that to happen. We want to stay at the moon. So once we get into that encounter, we're going to do some more burns to get ourselves captured in orbit around the moon. And there's a couple things that I didn't talk about in part 1 about the Navball when you set up a maneuver node. It will give you a estimated burn time and a time until the node that you set up. You know, we're node in T-minus about 17 minutes here as we time accelerate. And with our current thrust to weight ratio, the game is calculating that it's going to take about 2 minutes and 10 seconds worth of burning at full power in order to fully realize this change in our velocity to get on this new trajectory. And since we can't just dump out all of our thrust instantaneously and get this new velocity added to our original one instantaneously, what we want to do is take that estimated burn time and cut it in half to 1 minute 5 seconds. And that's where we want to start our burn, about 1 minute 5 seconds out from our maneuver node. That way we are burning evenly in time on either side of that maneuver node, because otherwise, especially with a long burn like this, if we burn, you know, if we only start our burn when we hit that maneuver node, we'll be burning almost entirely after the maneuver node, and so it's not really going to end up giving us the trajectory that we desired. And just a quick note about the rocket that I designed here. It is insanely over-engineered for going to the moon. I decided to put together a rocket that ended up having a lot of delta V in orbit, so I could use the same game save to demonstrate various different things you would want to accomplish in game. This rocket is even over-engineered a little bit, even for getting to Duna and back. So it's definitely got way more delta V than we really need to get to the moon and back. But that is okay. So we've started our burn here. We've aimed our rocket at that blue maneuver node, and as we're burning, that maneuver speed meter to the right of our nav ball is counting down. So at any given moment, it is telling us the amount of delta V that we have left in order to change our current velocity into our desired velocity and get that orbit out into a trajectory that'll get us to the moon. And another thing about how all these orbital mechanics work and how physics works in this situation is that it's kind of exponential in a way. You know, most of our delta V is spent just pushing out our apoapsis a little bit in the beginning there, but as we continue to burn and as we continue to push out that apoapsis, each additional meter that we put out that apoapsis actually becomes easier to push out. So as we're burning at full thrust, that apoapsis is actually going to accelerate out towards our target. So as you get close to running down that speed meter, as you get close to pushing your apoapsis out to where you want it to go, it's generally a good idea to throttle back some, maybe even kill the engines, and then start up again with just a little bit of thrust to get out that last amount of delta V without overshooting your mark. You know, at first our apoapsis was kind of creeping along, but you can see it's starting to go a little faster now. And also, as you get towards the end of your burn, the blue marker on your nav ball, the maneuver node marker, might start to wander a little bit. Because even though visually it looked like we had our target right on that maneuver node, maybe, we were 1/10 of a degree off somewhere, so we weren't really pointed exactly where we needed to point. And that will show itself at the end of the burn, as the blue maneuver node may wander a bit. So if it wanders on you, just go ahead and follow it and keep burning in the direction of that maneuver node. And here we are at the end of our burn, just making some slight adjustments to get that periaps down to what we want it to be. As you can see at this point, it's very touchy, and a little bit of burn goes a very long way, so I'm being really careful with it. But there we go, we've gotten our periaps all the way down to about 11,000 meters, maybe a little closer than the 15 we had intended, but that's okay. We can definitely work with that. And because we were careful with our burn, because we were careful with how we set up this maneuver node, we won't really even need to make any adjustments along the way. We're going to hit it here on our first try. And now as I time accelerate here and speed up the video in order to get us to the moon a little faster, it's a good time to point out that it's generally not a good idea to cross those barriers into encounters while you are under time acceleration, because the physics engine might get a little bit off, and it might ruin your carefully planned periaps and throw it off in some unexpected direction. So you want to be careful with that time acceleration. And for a moment here, I kind of considered setting up another maneuver node and doing a correction burn to get us to that 15,000 meters we were aiming at. But we really don't need to, so I'm just going to show you how to do it once we are in the encounter with the moon. And here we go. We are into our moon encounter. So I told you in part 1 how the nav ball always orients itself according to the celestial body whose sphere of influence you're currently occupying. Now that we're in our moon encounter, we are occupying the sphere of influence of the moon, and so the nav ball has oriented itself according to the moon. So if we're pointing at the dot at the bottom of our nav ball in the orange area, which we just passed over there for a second, we were pointed straight at the moon. But if we swing on around in our cumbersome vehicle here to the top of the nav ball, to the dot in the middle of the blue area, then we are pointed directly away from the moon. And so our orbit isn't exactly what we want it to be. It's a little bit inclined, as you can see here, and we want to go ahead and fix that. And it's cheaper, fuel-wise, to fix these kind of things the further out you are, so we want to go ahead and do this right away. You'll remember from part 1 that south is found along the 180 degree line, and south represents pulling on that bottom purple triangle handle there. So we can pull on that handle, and you can see by the orange dotted line what it's going to do to our orbit, and it's going to get us into it's going to get rid of our inclination and get us into a better equatorial orbit. But we didn't really necessarily even need this maneuver marker. As you can see, the maneuver node direction that it's set up for us here on the navball is basically right along that 180-degree line on the navball, which once again represents south. So we could have just swung around to the 180-degree line here and given ourselves a little burn, and that would have fixed our inclination. There you can see we're pointed south in relation to the moon. And we do have our maneuver node set up here anyway, because I wanted to demonstrate it, but we really don't need to wait for it in order to burn. We're pointed in the right direction already, and the further out we are, the less fuel it's going to cost us to make this change. So we can just go ahead and start burning now, and moving our orbit up into a more equatorial inclination there. And as you can see, as we're burning, it's slowly moving up to that expected new orbit there. And there we go, we've kind of fixed our inclination. We're no longer at a weird angle. But the next thing we're going to want to fix is our periaps. It's at about 11,000 meters, and that's a little close. We're going to want to take that and push it out just a little bit, maybe around to 15, maybe all the way up to 20, but we'll see. And you'll remember from my first video that orienting yourself on your direction of travel on that prograde marker and giving yourself some thrust will speed you up, and it will push out the opposite side of your orbit. But in this case, we're not at our apoapsis, and our apoapsis would be the best time to do that, to push out our periapsis. We're in some other random place along the middle of our orbit. So if we go find our prograde marker here, and we burn along that prograde marker, it is going to speed us up here a little bit. It is going to push out our periapsis a little bit, but it's not going to be fuel efficient. It's going to take a lot of burning and a lot of time to push out that periapsis if we try to do it this way. You know, we could set up a maneuver node for us, but we really don't need to here. All we need to do is realize that as we're looking at our screen here, we want to push our orbit to the right. You know, and the right in this case is basically the same as east. So we can point our ship along that 90-degree line, which is the east line. And since we are in an equatorial orbit, east will be found at the intersection of the horizon line between blue and orange and that 90-degree line. So as you can see, my big behemoth of a ship here is pointed east. It's pointed to the right. So now if I burn in this direction, our periapsis is going to go up quite a bit with just a little bit of fuel. And there we go. We got it all the way up to 14,000 meters, which is a little bit better than 11, a little safer. So it's right where we want it to be. Now the next thing we want to do is get caught in orbit around the moon. And we can do that by setting up a maneuver node right on that periapsis. And once again, pulling on that retrograde handle represents burning in the direction of the retrograde marker. That slows us down, and that pulls in our apoapsis on the opposite side of the orbit. So that's what we do. And we go ahead and pull on it until we bring in that apoapsis all the way to the point where we get into some sort of a circular orbit here. Now, once we execute this burn, we're no longer going to be flying by the moon, but instead we are going to be getting ourselves in a very close orbit to it. So here we are close into the moon, close into that maneuver node. And as you can see, as we approach that maneuver node, because basically all we pulled on was that retrograde handle, which represents burning in the direction of our retrograde marker, our blue maneuver node marker is, coming in to align itself with our retrograde marker. But since we ditched a stage here, what I'm doing is just a quick burn to let the system reorient itself and recalculate what our estimated burn time is going to be with these new engines and new weight. So now that we've got a correct estimated burn time, we can go ahead and wait for that maneuver node and kind of evenly burn around it and get ourselves captured in moon orbit. So once again, this ship is way over-engineered for a trip to the moon. So I ditched that last stage with plenty of fuel, and I'm going to ditch this current stage with plenty of fuel left in it because we really don't need it. And this particular stage isn't really set up for landing, it's set up for interplanetary transfer, so there's no landing gear on it. But as we execute this burn, we transition from a flyby of the moon into orbit around it, and we keep pulling in our apoapsis all the way down to where we want it to be. And sort of that exponential nature of changes to orbit works against us here, and in the opposite direction as it did before. Now we're bringing in our orbit, so it came in really fast at first, but now that we're approaching a very tight circular orbit, it's starting to slow down, and it takes more delta V to get it to move just a little bit. But eventually, it does keep on coming down until we get it to where we want to be, and we get ourselves in a nice tight circular orbit around the moon. So here we are in orbit around the moon. We've ditched our last stage, we've extended our landing gear, and we've kind of swung around to the leading edge of the light side of the moon. Because we want to land on the light side. Landing on the light side gives us a shadow, and the shadow is typically the best indication of how far away the surface is when you get in real close there. So what we want to do here is find a spot underneath our orbit that looks pretty flat, add a maneuver node, and then pull on that retrograde handle, which represents slowing down, until our expected trajectory is almost straight down at the surface. This isn't necessarily the most fuel-efficient way to land on the moon, but it is probably the easiest way to approach it. And once again, all we did was pull on that retrograde handle, which represents burning in the direction of the retrograde marker. So as we come up on this maneuver node, the maneuver marker on the ball, the blue target arrow, is going to align itself with our retrograde marker. And yet again, I have dropped a stage, so what I'm doing here is just giving myself a quick burn up to full thrust, so that that maneuver node will recalculate the estimated burn time based upon what my thrust and weight of my vehicle is now. And now that we're close to that maneuver node, our maneuver target on our navball is lined right up with our retrograde marker. We go ahead and burn, and this kind of kills all of our orbital velocity. That's the point. We want to get ourselves in a position where we're falling pretty much straight down at the surface of the moon. Now at this point we want to switch our navball mode by clicking on that velocity up top there to surface, because that's where we want to land. You know, we need to take the moon's rotation into account as we're coming down for a gentle landing here. And as we're coming down, we want to make sure that our movement is straight down to the surface. We want to get rid of any side-to-side motion, any northeast, south, or west. So as you make burns near your retrograde marker, it is going to want to move away from where you're pointing on the navball. And the object here is to shepherd that retrograde marker right up onto the dot on the top of the blue side of the navball. And there we go, with just a couple of quick burns there, we pushed that retrograde marker up right where we want it to be. So now we're pretty much falling straight down, and when we come down and touch down on the surface, because we've killed almost all of our north, south, east, or west velocity, we're not going to tip over. So as we start getting close to the surface here, a little bit under 5,000 meters, we're going to want to do a burn and kill all of our vertical velocity and get it so that we just barely go up a little bit. And what that's going to do is cause our retrograde marker to kind of fly off to the side there, and that shows us what is left of any kind of lateral movement that we have. And then we can go ahead and turn and do a quick burn there to push that retrograde marker right back up on the dot. Because when we are going really fast, you know, like 100 meters per second or more, you know, just a little bit of lateral movement, you know, maybe only 1 or 2 meters per second, is really not going to be noticeable on the navball. But if we slow ourselves down to almost 0, it's really going to jump out. So at this point, what we want to do is kind of search around and find our shadow, and it might be kind of small and distant and a little hard to find. So let's, there's the sun there, so that means our shadow should be right about down there. There it is. And that's important because as you start coming down, your shadow's going to come around up to meet you. And with the current interface in the game, that is the best indication of how far away you are from the surface. So as we start getting down closer here, we want to get our speed down below 5 meters per second so that we touch down quite gently. You know, we just keep finessing the amount of thrust we're giving. Shift to go up, Control to go down, or X to kill it completely. And you can see our shadow's getting bigger and bigger, and it's coming closer to us, indicating that we're starting to get pretty close to the surface. And now it's time to be really careful with that speed and make sure we do keep it below 5 meters per second. But don't overdo it and start heading back up, then we'll just be wasting fuel. And you can see we've got a little bit of lateral movement left, but not really enough to worry about. And we should be able to touch down here safe and sound. There we go. We're on the moon. We can now EVA, plant flags, get some samples, but we're going to skip over all that and head right into getting off the moon and getting home. Now, typically when you take off from Kerbin, you take off pointed along that 90-degree line, which is east, which will put you in an easterly orbit. But we don't want to do that here. We want to go west. So as you can see, we aimed ourselves at the 270-degree line, which is the opposite side of the nav ball from the 90-degree, and it has started us off in a westerly orbit. You know, the moon has much lower gravity and no atmosphere as compared to Kerbin, so it only took a short burn there to get us a decent apoapsis for the moon, which is about, 20,000-30,000 meters. So we are going to just wait until we get up to that apoapsis, and then we are going to point ourselves at the horizon line, right where our prograde marker is going to meet us, right as we get up to that apoapsis, and then execute a burn, and that will push out our trajectory into an orbit around the moon. And since now we understand all these concepts, we didn't have to set up a maneuver node for this. We just know that burning in this direction at this time is going to create us an orbit, and here we go. You know, it may not be the prettiest orbit of all time, but it'll do. And the reason we wanted to go west instead of east is, remember, whenever we burn along our prograde marker in orbit, it is going to push out the opposite side of the orbit. So to get back to Kerbin, we want to set up our maneuver node on the opposite side of the moon from Kerbin. And since we are in a westerly orbit now instead of east, our prograde marker and this burn that we're going to execute is burning against the direction of travel of the moon's orbit. You know, we're orbiting around the moon, but the moon is orbiting around Kerbin. So we want to kill the velocity that the moon's orbit imparts to us. And as you can see, setting up a maneuver node in this manner gives us a nice close periaps to Kerbin. Actually, I pulled it a little too far and we were going to hit Kerbin. But now we've got ourselves a maneuver node set up for about 35,000 meters, which is about perfect. That'll bring us home. You know, if we wanted to go straight into landing on Kerbin without burning our engines at all, we would probably want our periaps a little bit lower than that. But either way, this will get us home. So the video's already kind of run a little long. There's no reason to show you the burn home because you should understand this by now. And never fear, there's going to be a part 3 and part 4. Part 3, we are going to go over how to get to another planet, in this case Duna. And in part 4, we are going to show you how to do an orbital rendezvous with like a space station that you've set up around Kerbin. Thank you everybody for watching. We've got more parts of this tutorial and more videos besides that coming out soon. So please hit that subscribe button. And, you know, get out there. Go land on that moon. Bring back a sample. Find out if it's actually made of cheese or not.